Okay, welcome back. So we continue on protection, yeah? 10.6. So overview. So file owner, yeah, and or creator, either of these, should be able to control what can be done and by whom. So type of the access, either read, write, execute, append, delete, or list. So these are the type of access. Yeah. Okay. For the protection, yeah. So under access control verification module. So file sharing, yeah. So it consists of data file, user own program file, and also system file. Yeah. Advantages. So when we do file sharing, we can save a space, synchronize data, update system resource efficiencies. So means I operation can be reduced when we do sharing. Yeah. So IO operation we can reduce also because of the sharing. Yeah. All right. So disadvantage, yeah, need to protect file integrity. So that's why we need to have this kind of things. What is this? Access control. Yeah. So in access control, there are two techniques, which is here that you can see access control metric, and also the next one is access control list. Yeah. So access control matrix or ACM. Yeah. So an access control metric abstract the state relevant to access control. This method shows the access right for each user for each file. For example, user one, yeah, user one allowed allowed, yeah, unlimited access to file one, but is allowed only read and execute file 4, and also is denied access to the 3 other files, such as file 2, 3, and 5. So here are the things. Or user one. We're talking about user one. So here, short form for R mean read access, W for write, E for execute, delete for delete access, and dash for access not allowed. Okay, so that explanation for user one for each of the file. Okay, that's kind of the protection. All right. Okay. So advantages, access control metric, so easy to implement and works very well in system with a few file and also users. So these are advantages of access control metric. So the advantages of access control metric, such as a file and user increase, so that metric size increases. So possibly beyond main memory capacity. Okay. All right. So it also, when the user increases, so wasted space due to null entry. Okay. Right. Wasted space mean we create that, but not on the demand. Sometimes we use, sometimes we not. Okay. So that's create the condition of the wasted space. Yeah. Right. So example 6b, the 5 access code for user 2, yeah, from example 6a. So the resulting code for each, yeah, for each file, yeah, is created by assigning 1 for each check mark, and 0 for each blank space. Okay, all right. So for the file one, yeah, for the file one here, start with the file one first, for example. Okay, so means we give permission for this file actually for read only R. Okay, this one for write, and then this one for E for execute, D for delete access. Okay, this one reflect to this type of the access. And then we allow this file to be read. That's why here we got one. Okay, so the first one. So if not allow for this purpose, so you have to put 0 here. Yeah. So this one we allow that. So that's why here is a 1. And we not allow for write and also D for delete. So that's why you can see that this is 0 and final one is a 0 as well. And but we allow for the this for the E for execute access, this one. So that's why you can see here 1. Yeah. All right. So this one similar for the rest of the file. All right. So now we have another kind of the method we call access control list. Which user are allowed to access each file. It is the most general scheme to implement independent access to associate with each file and also directory, the specified username and the type of access allowed for each user. All right. Example 7. SCL method require less storage space than access control matrix. Yeah. All right. So we got the file, and then we got the access for each of the user. We got how many user here? 1 here, 2, 3, 4, 5, and this one may be a user as well. All right. And this is the type of the access they give to each of the user. Okay, this one for user R2, this one for user R4, this one for user 5, okay, and then this one for world. Okay, and similar for the rest, file 2, file 3, and so on. Yeah, all right. So contains a username actually, yeah, granted for file access with SCL. User deny access group under, okay, they put the name, okay, world, which is a deny group, yeah, deny group, keep in the group of the world. So shorten list by categorizing users. We got system, which is personnel with unlimited access to all files. We got owner, absolute control over all files created in own account. Okay, group, all user belonging to appropriate group have access. Okay, like this. This one is permissible, open, allow group. Disallow, deny group. So all other users in the system, if we want to deny, put in this group, for example. So this is the purpose of the grouping, actually. Yeah. All right. So, for example, Unix scenario. Yeah. Solve the problem of directory size by classifying a user into 3 classes. So in Unix, we got owner, group, and also universe, all or public. Okay, so your owner is a user who creates that file. A group, a set of users who are sharing the file and need similar access. There's a group, and another one is public. Okay, all right. So 3 groups, yeah, or 3 classifying user or 3 group of user in Unix. Or here they call 3 classes of users. Yeah. So define 3 bits to represent each of the class R, W, and also X. So how many bits? 3 bits. Okay. So for example, RW dash R dash dash or dash dash dash. So indicates owner has RW access, and then next is a group has R access, and public has no access. Okay, the first 3 bits. Okay, define 3 bits to represent each of the class. Okay, so the first 3 for the owner. Next 3 is for group. Yeah, and then next 3, another 3 is for public. All right. Okay. So example 8A. With each file and subdirectory, we keep 9 protection bits. 3 for owner, 3 for group, and also 3 for public. All right. So this is the 3 groups or 3 classes of users. Okay. So owner access, okay, which is 7, which is 1111. Yeah. And then for the group is a 4, the value of the decimal. So this is 100. Okay. So this is binary. So convert to decimal is a 4. Public access is 5 by this binary. Okay, we got R and then not allow and execute. So 101. Okay, so this is in binary. Convert to base 10 or decimal. So we got 5. Okay. So Unix 8B. So Unix in Unix environment, yeah, Unix environment, set protection for file games using the command chmod or change mode. Yeah, all classes, all user classes can read the file. Only owner can write, and also owner and public can execute the file. All right. Okay. So this is the the command that we going to use in order to reflect to this requirement. Okay, this is a requirement. So through this instruction, change mode 745 game. Okay, all right. Owner and groups. Right. So another example, a sample of unique directory listing. Yeah. Here, file. Okay, file. You can see the file is written like this. We got 1, 1, 2. Oh, sorry. Okay, no. Okay, there's a true 3 classes. Yeah, 3 classes of this. Okay. All right. Okay. So what is the next? Okay, so honor. We got honor, 3 groups, 3 honor, group, and public. Okay, all right. So there are 3 groups. So means 3 bit for each of the group or category. So explanation about this scenario. So into.ps, into.ps where? Here. This one, yeah. This is a file name intro.ps or into so whatsoever. So this is a file. Okay, it's a file owned by PBG. So this is owned by PBG here. It's stated here PBG. All right, and then with the group staff. So this is a group of staff. Okay, and And also this is a lib. The next one is LB. LB is this is a what? Subdirectory, because we got slash at the end. Subdirectory owned by PBG group. This is PBG group. Yeah. And then with the group of faculty, the group of staff, the group of faculty here. Okay, this is explanation, okay, from this content of the directory, yeah, one of the directory. Okay, here, so we do, okay, similar that here, file, we have the file and also the directory. Okay, because the directory start with the D and also this a dash is a file, all right. So same thing here, all right. We got every file and also directory. There's a 3 class, okay, owner, group, and also public, yeah, all right. And all user can read the file, cannot execute at the beginning here, okay, from the setting that they are set here, okay, yeah. All right, so all user can read. So there is a read, R, each class, there is R. Okay, and then cannot execute. There's no dash mean each of the class not cannot allow. And only owner can write. Owner at the beginning can write here, W. Okay, can owner, not for the this one for the group and also the public. Yeah. All right. So all another example, all user cannot read. So if you check properly here also, so cannot read. Okay. Here dash, here dash for the owner, for the group, and also for the public. See? All right. So, but they can execute. So each group or each class can execute. We got X here. Okay. All right. So allowed to execute. Right. So only owner can read the next one. Okay. Read, write, and execute. Group and public cannot access the. Okay. So given, so this exercise, okay, exercise, just you can go through. Okay, this exercise, given a sample unique directory listing. Yeah. So this one, example of Windows 7 access control list management. All right. Summary. This is a file, an abstract data type defined and implemented by operating system. A file is a sequence of logical record, actually. Yeah. And OS needs to map the logical file concept onto physical storage devices. A tree structure directory allow a user to create subdirectories to organize file. Access to file can be controlled separately for each type of the access, such as read, write, execute, and also finally delete. Yeah. So this is exercise that you can go through in the textbook. Yeah. All right. Okay, that's all. Thank you for listening and watching. See you next. Bye bye. Assalamualaikum.